Okay, so 9.7, we're going to talk about chord theorems, and this could also involve secants. So a secant is going to be a segment of a secant line that has exactly one endpoint on a circle. So I think of secants as a segment that goes through a circle. Okay, so like BC is a chord, and then AC is a secant, if that makes any sense. All right, so we're specifically going to learn a theorem about the external part of the secant. All right. And so if we look at this example, and we can continue with arrows, or we could just stop at this point A. But what it basically says is we have secant AC and we have secant AE. And we want to think of these as parts. So I can think of this as, let's just say that's one. And then I want to think of the whole part, okay? And so it says that the product of those is going to be equal to the product of the other secant. So I've got AB times AC. And that's going to be equal to this part and then this whole. So AD times AE. So I think of it as the outer part times the whole equals the other outer part times the whole. Okay? All right. And so that's if we have two secants that are connected. All right, let's look at example number 1. And I have a couple just because it's different for solving. So if we look at this secant, I've got the outside part times the whole part, which it's x plus 8 when you put those together. And that equals the outside part times the whole, which 10 plus 6 gives us 16. So if you can put it together, please do. It makes it look simpler, but it's easier to solve. All right, so on here, you're welcome to solve this a few different ways. I'll distribute 8 times x, 8 times 8, and then 6 times 6. We want to solve for x, so I'll subtract 64. So 2, 3 equals 8x. And then those are being multiplied, so we'll divide by 8. So x equals 4. And that's what we were looking for, so we would be done. Typically, these are going to be nice integer values, but you'll want to show on your quiz the formula. Right? Okay, let's show a different one. So I'm going to do the outside part times the whole. Once again, it's x plus 9. And then this outside part times the whole. 5 plus 4 is 9. Okay, so on this we'll distribute. So x times x is x squared. X times 9 is plus 9x. It's 36. Now, we do need to get everything to one side and factor. Otherwise, you could use guess and check to see which one's true, but the technical math way is to get all terms to one side and factor. So we're going to subtract 36, which just moves it to the left. So x squared plus 9x minus 36 equals 0. Now, if you're not good at factoring, or if you don't remember this from semester 1, I totally understand. You would just want to keep plugging in numbers like 1, 2, 3, and see which makes this true. All right. But if I factor, I want to use the what times what gives us 36 that will add to give us 9. So I think, how about 3 times 12 gives us 36. If I add 3 and 12, I get 15. If I subtract, I get 9, which is what we want. So we want this to be 12 minus 9. Now, if I would have picked different factors, it wouldn't give us 9. So let's say I did 6 times 6. 6 times 6 is 36. But if I add these, I get 12, and I subtract them, I get 0. So that's how there's only going to be one set of factors that works. So since I know this, it's going to be x minus 3 and x plus 12, because those were the factors that worked. Then we set each of these equal to 0. And this is from the end of semester 1. It's from quarter 2. But factoring is a pretty important part of this course. Now, we do get two answers. We can't have a negative length, so this is called an extraneous solution, and we cross it out, and we just end up getting 3 as our solution. So if we were to plug that in, 3 squared plus 9 times 3 gives us 36. If you don't like factoring or using the quadratic formula to solve, then as long as your answer is an integer, guess and check is okay. But if my answer would have been 3.2, you're probably not going to find it if you use guess and check. So that's kind of the downfall. All right, let's look at example 3. So we've got the outside times the whole, which would be 19, equals the outside times the whole. Now, this one, you're only going to have one x, so there won't be factoring. So 7 times 19, so 63, 6, 133. We'll distribute, so 6x plus 36. We'll subtract 36. So 6x equals, I believe this is 97. Yep. And then divide by 6. So 97 divided by 6 is a decimal. So I get 16.16 repeating, or the best answer is if we leave this as 97 over 6, and it doesn't reduce, so this would be the exact answer. So exact, and this is the approximate. So there are times when you're going to get a decimal answer for some of these, okay? All right, let's learn about our second theorem. So this time we have a tangent on one side, so JK is a tangent, and then we have a secant, okay? And so the theorem that we're going to learn, or the rule, is that the tangent squared, so I'm going to say JK squared, or tangent, is equal to the outside, so JL, times the whole, JM. So this is the outer secant times the whole secant. Okay. So this is a little harder to memorize, but remember, you can make a formula sheet. So let's look at example number 1. So this is my tangent because it's touching the circle, and then QS is my secant. So you want to first identify that. So we get our tangent squared, so 8 squared is equal to my outer times my whole. So the whole would be 12 plus x, or x plus 12, either way. Now, you can try guess and check, but you know I'm a solver. So x times x, we're going to distribute x times 12. As long as our answer is an integer, then this would work, but we want to get everything to one side. So I'm going to subtract 64, which just puts it at the end. So remember, the zero product property is what allows us to factor, or you could use the quadratic formula. So as a refresher, remember it's negative b plus or minus b squared minus 4 times a times c all over 2 times a. If you need help solving these problems, though, I can meet with you one-on-one and we can work on factoring or the quadratic formula to see which one suits you best. All right, so we need the factors of 64, what times what, that will add to give us 12. So I just think 8 times 8. If I add them, I get 16. If I subtract them, I get 0, and I want 12. So I know those are not the factors. So I need to think of another number that divides into 8 because that'll also divide into 64. So I think of 4. So get a calculator and we divide 64 divided by 4 is 16. Well, if I add those, I get 20, and if I subtract, I get 12. So I do want to subtract, and I'm going to get positive 12. So I'm going to have 16 minus 4. See how I put the signs there? So then those are the terms that go with the x. So we get x minus 4 and x plus 16. There's lots of different ways to factor these. We'll split those up into our two equations. Add 4. subtract 16. And I know x can't be a negative length, so this is an extraneous solution. So we want x equals 4. All right, let's try example number 2. So we have our tangent squared, which is 10. So 10 squared equals our outer secant times our whole secant. So my whole secant would be x plus 4. So x plus x is 2x plus 4. All right, and we're going to distribute. So I get 100 equals 2x squared plus 4x. I do want to subtract 100 so I can get everything to one side. So 2x squared plus 4x minus 100, and that equals 0. Now, we could factor this, but the better strategy is to divide everything by 2, so this will be a little bit easier to factor. It really does make it hard. You have to do the AC method when you have a number in front of x squared. So we are going to divide all terms by 2. That's being fair. So this is what we get. All right, and now I need the factors of 50 that will give me 2. I know 5 times 10, but if I add, I get 15. If I subtract, I get 5. I want a 2. 25 times 2. So if I add, I get 27. If I subtract, I get 23. Well, that's not going to work either. So what does that mean? That means that this is not factorable. Okay, so we really don't have a choice. I do need to do that quadratic formula. So I'm going to put a 1 here for A, B is 2, and C is negative 50. So we have the opposite of B. So the opposite would be negative 2, plus or minus. We've got B squared minus 4 times A is 1 times C is negative 50, all over 2 times A. So we're going to type this into a calculator. I get 4 plus 200, so 204 all over 2. And then 204 isn't nice, but I can go ahead and we'll break that down. What is that? 4 times 51. So the square root of those, I would get negative 2 plus or minus 2 root 51 all over 2. We know we're not going to have the negative, so I'm going to end up with, if I reduce all of these by 2, I get, we've got negative 2 plus 2 root 51, because we can get rid of this negative. A negative and a negative will stay negative. We can't have a negative solution. But all 3 of these outside numbers reduce by 2, so we end up with negative 1 plus root 51. And that would be the exact answer. Okay, that was tricky.